In this case, we want to look at converting from polar notation to rectangular notation. We're going to do two examples here to show how to do a conversion from the polar rotation to the rectangular notation. I think the first important step in doing any of these conversions is to draw out the vector we're looking at so that we can see exactly what we are working with. In this case, we know 0 is the positive x-axis here. We're going counterclockwise past 180. It's going to be down here in this third quadrant. It's going to be 85 meters long at 205 degrees. Now we have two options here on where we're going to put the x and y components. We could put the x and y components on this side down by the 270 or by the 180. I'll put two different colors here to show that. One version, we would put our y component here and our x component here. If we do that, the angle that we're working with is 270, which would be down here, minus 205, so 65 degrees. The other option would be, the second option would be to place our x component here and our y component here. In this case, it would be 205 minus 180 to figure out what this interior angle is. So in this case, we would be at 25 degrees. You should see that the blue angle and the green and the yellow angle add up to 90 degrees, as they should. So we have two options to work with. I'm going to show for this example as if we were working with the blue option. So we have 85 long, we have our x, our y, and our interior angle is going to be 25 degrees. The yellow would have been x and y up here. Here's our x, here's our y, and our angle would have been 65 degrees. So I want to solve for the two sides. Now this just becomes trigonometry. To solve for the x, I'll use cosine. Cosine of the angle equals the adjacent over the hypotenuse. So the cosine, our angle in this case is 25 degrees, is equal to the adjacent, our x, over our hypotenuse, 85. Cross multiply, 85 times the cosine, 25, will equal x. From that we get 77 meters long. For the y, I'm going to use sine. Sine of the angle equals the opposite over the hypotenuse. So the sine of 25 equals the y over 85. 85 times the sine, 25, equals y. Y in this case comes out to 35.9 meters. So my x is 77, my y is 35.9. My final answer will be my x component is going to the left, so I need to make it negative. And my y component, which is going down, negative 35.9 meters. So it's 77 meters by negative 77 meters by negative 35.9 meters. In this second example, we have 25 meters at 10 degrees. This one's a little bit more straightforward because we know our angle is right here. We're going to make our x and our y. It's 25 meters long. So in this case, the sine of 10 will equal y over 25. So 25 times the sine 10 will equal y. It comes out to 4.34 meters. And the cosine of 10 will equal x over 25. So 25 times the cosine of 10 will equal x, which will be 24.6. So in this case, our x, positive to the right, 24.6 meters. Our y, positive 4.34 meters. So there's two examples of breaking down our polar notation into rectangular notation. There will be another video up which does the opposite, going from rectangular notation to polar.